First of all, thank you very much for inviting me to give this talk. I will briefly describe the activities within WG2. Basically, WG2 works on the title of this working group is, excuse me, The Life and Death of Stars. What does this title mean? Basically, Gaia, the working group is based on what Gaia gives us in terms of distances, luminosities, temperatures, ages, extinction, and kinematic information for the stars. Putting all this information together, and in particular the parallaxes that can give us a direct measurement of distance, we will be able to obtain HR diagram well calibrated from the Premian sequence to the white dwarf sequence. And Despina has already shown before one of those beautiful HR diagrams coming from DR2 and from DR3 as well. I mean, the one from the Large Magellanic Cloud. So the main purpose of WG2 is to study, to combine the information from Gaia and to interpret the observed color magnitude diagrams that become absolute HR diagram because we have the information on parallax, and distance and absolute magnitude, but also the information on the colors of the stars from the two filters from Gaia and the temperatures. And this brings an enormous amount of information, in particularly with the data that already we have from previous data releases, but also with the new Gaia release that will become available with DR3 in June. We will have, and we already have, the possibility of study, for instance, star clusters and derive information how the stars formed, test the models and test the theories by which the stars form in clusters and then spread all over the galaxy. So we will be able also to measure mass function, star formation easily, and whatever. Basically, so we will be able with Gaia data to trace the life of a star till its death in the different evolutionary phases. The objective of WG2 are, in fact, throw new light on the stellar constituents of the Milky Way, develop a strategy to fully exploit and optimally utilize Gaia data to gain insight, to gain new insight on how stars form, and testing the scenario from which most stars form in clusters. Then will allow us, and already are allowing us, to improve our understanding of stellar models, basically through the analysis, the comparison between the very good, accurate and precise HR diagrams and that Gaia provides and our models in stellar evolution models, and also compare the ages that we derive, for instance, from isotope fitting with the ages that we can infer from asteroseismology. The working group is organized in three tasks, works around three tasks, WG2, WG2A, which is stellar atmosphere, which deals with stellar atmospheres and spectroscopy, WGT2B, stellar models and age, 3D modeling and stellar interiors, modeling microscopic and microscopic processes in stars, and then WGT2C, that deals with stellar clusters and star with asteroseismic constraints, including all the stellar evolution phases and also phases where the stars are variable, like, for instance, Cepheids and Arolari that are in a specific phase of stellar evolution. The group, the team, the working group has a large number of subscribers. You have here the structure. It is organized with task leads. This is simply to get you familiar with the activity and how the group is organized. And now let's go to the activities of WG2. Mainly the activity, as all the other working group in the cost action, we had this unfortunate situation of COVID that has deeply affected the work also for our working group. Nevertheless, we have managed to organize a number of meetings, school, and here I listed the activities that we have done in this first year and a half of the cost action. And I've also highlighted in particular the two events that have really marked the progress in our work. Gaia EDR3 that occurred on 13 December 2020, and then the full Gaia Data Registry that will be in less than a month from now. There have been a number of workshops and in the school organized by the working group 2. The first school has been, the first workshop was a workshop on frontier of stellar physics, theory, observation interface that took place in Croatia, in Zagreb, Croatia, in January 2020. Just, that was the only event that we could really do in person. And then there has been a school on spectroscopy and astrophysical parameterization from Gaia to large spectroscopic survey that took place in September 2020 and was already online. And then a workshop on star clusters, the Gaia revolution, that took place in October 2020. And there is a coming meeting organized jointly by WG2 and WG1 on stellar evolution across the HR diagram with Gaia that will take place in September 2020 in Naples. And I will tell you more on that. The meeting to be in person, but probably will be hybrid. We'll have a hybrid format also to allow a larger participation of people. Then there is another meeting that is foreseen for the last year of the cost action, and this will address more specifically stellar variability, stellar multi-periodicity in time and motion. Let's see a bit what those meetings have discussed. The meeting in Zagreb, you have the photo of the meeting here, which was the only one that was in person, was a nice meeting with about 40 participants, a lot of young people, and we touched basically, since it was a starting meeting in a way, we touched basically all the main field that we want to address in WG2. First, we started, since this meeting happened just before DR3, sorry, but we were already preparing for the first installment of Gaia DR3. There was the presentation of an update on Gaia and on the main aspect of the release. But there were also indication on what is the connection with the stellar physics coming from the information coming from Gaia DR2 and EDR3, and the constraints that can be obtained with combining the data with astroseismic constraints. There were also, in particular, focus on the importance that Gaia EDR3 would have had on the distance scale. Even if this is not exactly a topic addressed within WG2, and I think that Sonia and Tom will expand more on this, since this is a topic specifically of WG4, distances are enormously important for WG2 because we need the distance to have a calibrated color magnitude diagram to compare with with our stellar evolution models. And a clue point of this distance is the importance of the parallaxes, the problems that Gaia parallaxes may have, this problem of the offset, the 0-point offset existing on the Gaia parallaxes was discussed quite significantly in this meeting in Zagreb, trying to find way out to solve this issue. And also both using astroseismology or getting constraints from astroseismic parallaxes, but also from pulsation models of stars. And in particular, from stars that are standard candles, like Cepheids and Aralaris. I will expand a bit more on this later. And then we also had a number of reviews on population models and star counts in the Gaia catalog, all information that are crucial to understand the color magnitude diagram and to link it to its interpretation in terms of stellar evolution. From this meeting, there was a number of works were presented at the meeting, and also a number of studies were triggered by the interaction that we had during this meeting. I have listed here a few of them. This is a very biased, if you want, selection, but still I think it's important because, as I said already, the distances and the information parallaxes that Gaia provides are a crucial point, are a crucial starting point for any comparison with the models. And there are a number of papers that I would like to point out. One is on the period. We have a number of standard candles, which are diagrams that are used when the parallaxes are not, that are used to measure distances when the parallax is not good enough because these objects are too far away, or the system where we won't measure the distance are too far away. And these are the two types of pulsating stars, the Aralaris and the Cepheids, that we also find in open clusters and in globular clusters. And so there have been works on these stars as standard candles. You can measure distances because they conform to relations that are known as period luminosity relation in the case of Cepheids, or luminosity metallicity relation in the case of Aralaris. And there have been a number of works on this subject that have taken advantage of the EDR3 parallaxes, the new parallaxes published by Gaia in 2020. And the discussion, so these papers that I've listed here provide a selection, an indication of the most interesting paper, the works by Ripet et al. 2020 and 2021, where you have this relation, period luminosity relation calibrated Gaia pass bands, or the work by Rees et al. That again uses Gaia parallaxes in combination with measurement with HST parallaxes. And also for the Aralari, the luminosity metallicity relation of Aralaris calibrated on Gaia DR3. There is certainly a way of constraining the uncertainty in parallaxes of Gaia using astroseismology, and I leave this for Sanija Khan, who will talk. Now, new impulse, new really burst of activity has come from with the publication of DR3 in the description of, in the production of theoretical instability strips for Cepheids and Aralaris stars. In particular, I show here a work that is still a work by the Somme and collaborators that has been submitted to Astrophysical Journal Supplement that shows the boundaries of the stability strip for classical Cepheids and how the boundaries, the colors of the stability strip you have on the absolute luminosity on the y-axis and the temperature as infer the temperature on the x-axis, and you can see how the boundaries of the stability strip, the region where a star when is inside this region pulsate as a Cepheid, vary with metal abundance, and you have metal abundance that is increasing from the top to the bottom panel in each of the two sets of panels. And for varying helium abundance, again increasing from the canonical value of 0.25 top panels to 0.28 bottom panels, while also another important, moving from left to right, there is another important parameter, which is the mixing length parameter, that is the parameter that is used to describe convection in these stars. That also varies from the left to right. And this set of models is now used to interpret the observation we get from Gaia, and in particular the observations we will get that will become available with Gaia DR3. Another important point is this 0-point offset that is known to affect the Gaia parallaxes. And here in this plot, again from the same paper, you have the difference between the parallaxes inferred from the period luminosity or period bassinet metallicity relation that Cepheids follow, so a theoretical parallax, and the parallaxes of Gaia. And this difference gives you an idea how to correct for the 0 point. And again, this is done for different value of the mixing length parameter, alpha, and for different sets of data. And this is another way to, take advantage of Gaia data and compare them with models, in this case, pulsation models of Cepheids, to infer information and to infer correction of the Gaia offset. The other meeting that the school that took place during this first part of the activity of WG2 was the stellar spectroscopic and astrophysical parameterization from Gaia to large spectroscopic survey school that took place in Padua, September 2021. And here you have a highlight of this school. What was the focus of the goal of the school? The goal of the school was to illustrate the derivation of stellar parameters from spectroscopy and large survey pipelines using classical, high precision, and data-driven methods. So there were a number of lectures on the different methods, on the different way you can infer information on the metal abundance on the sources you are analyzing using the spectroscopic material. Coming from Gaia, Despin has shown before some of the spectra that will become available with the Gaia DR3, and that have been used to derive infer metallicities from this for sources that will be released in Gaia. But also, and this is very important for the work that we do in WG2, is the synergy between Gaia and the large spectroscopic surveys that are taking place in these days. With Lamost and Foremost in the future. This school was online. There were a huge number of registered participants, and on average, about 200 attendees per day. So the event was really important and followed. And there was also here the list of main topics that were discussed were the large spectroscopic survey, a review of all the spectroscopic surveys that are in place now or that will become available in the next future. For instance, the surveys, the public survey from Foremost will start soon, very soon. And then the methods to measure abundances, like equivalent widths, spectral synthesis, differential spectroscopy, and also a discussion about the advantages and limitations of the different methods, in particular given from people that is working on that Gaia data, that is like René André and Alejandra Recio Blanco, that have been working on the spectra that Gaia is providing with the RVS. And also there was a discussion about publication scale by Chris Nitin. Now, there were a number of presentations in this meeting, and I have selected this one. Actually, it was nice to see that not only spectroscopy in the sense of abundances were discussed during this meeting. This is a slide taken from a presentation done by a postdoc student, Alexandra Abdeva, which shows how combining Gaia data with spectroscopy from Lamost and Rave, it is possible, combining Gaia data in terms of astrometry and photometry for selected stars, it's possible to infer information on the extinction, on the absorption. Here you see in these plots a comparison between temperature inferred, the difference in temperature inferred from spectra taken with Lamost and Rave, and the differences in the plot on the right, derived by the two type of sources that were used, giant and main sequence stars, and then the absorption value in the V band derived using a distinction derived using a cosecant law in both directions. Then the other important benchmark of the activity of WG2 was this meeting that was carried on in Barcelona. It's star cluster, the Gaia Revolution. That again was planned to be a hybrid meeting initially, but unfortunately had to be fully online. And also, of course, these meetings that go online have the disadvantage that you don't have the direct contact between people. On the other hand, allow a much larger participation because even people that could not afford traveling for the meeting can attend. And in fact, in this sense, this meeting, the meeting on Star Cluster, was very successful. And there was a large participation with also feedback from the participants that were very happy of this way the meeting was carried on. And that from the point of view of main scientific results presented during the meeting, there was certainly the fact that there was a large number of coeval and co-moving structures that were found, new structures, new clusters, star clusters, which showed the potential of Gaia EDR3 in terms of identifying new open clusters and star cluster structure, even star-forming regions. Also, it was clear that although it is not possible, it is still not possible to model the structure, the dynamics of open cluster, as well as we can do for globular cluster now, still there was a huge progress in terms of statistics and also in the possibility of this increased sample of clusters, of open clusters discovered and structure on star clusters discovered, open the view for studies of, for instance, the structure of the spiral arms. I'll come back to this in a while. And also, again, the connection between asteroseismology and ground-based spectroscopy was highlighted in a number of books. Again, from this meeting, a biased selection of studies and papers that I have extracted from the literature was, for instance, the new catalog, the huge number of clusters, open clusters discovered in Gaia, EDR2 and then EDR3 data. And you have here a couple of papers, the paper by Cantat Godin that show based on Gaia EDR2, while the papers by Castro Girard et al. Are based on EDR3. And in one of these, sorry, there is a typo here. The number of new open clusters is 628, not this huge number here. But those clusters have been used to trace the spiral arm. And we will see result on this in EDR3. Another interesting result is this study of Westerlund 1. Westerlund 1 is an open cluster, which is about 4 kiloparsec from the sun. And this is work by Negaruela and Alfaro and collaborators. They have selected stars. They have obtained the color magnitude diagram in a region, basically around 12 arc-minute around the center of Westerlund 1. And you see in the plot on the left, in gray, the star contained in this HR diagram. While in red are shown spectroscopically confirmed members of Westerlund 1, studied by Clark et al. 2020. And they define basically a red giant, a red branch that is with colors larger, BP minus RP, rather than 4. And on the plot on the right, you see the maps, XY maps of the stars that are plotted, the stars of the cluster. In particular, on the top panel, you have the stars marked with squares, red squares, the red dots on the red stars in the color matrix diagram. While in the bottom panel you have is identity contour. Well, the plot is in proper motions, and you can see in gray all the stars in the clusters, and the red giants highlighted in gray. And you can also appreciate that there is a kind, the distribution is not of the red giant seems not to be symmetric with respect to the center of the ellipse. Now, this is for the cluster Westerlund 1 itself, let's say, for what we know. But then going to see also the distribution of stars in color, this author have found that there is a peak for colors rather than 4.5 that you can easily see in the top panel on the left. But there is also a concentration, less clear, less strong, of stars with colors bluer than 1.5. And if you plot the normalized count of these two populations in parallax, you see that they are offset. So this author claimed that in Westerlund 1, there are two populations that are separated, a red population that is with a parallax smaller, a peak in parallax smaller, which means it's much far away, and the blue population that you see in the right panel, both in X, Y, and in proper motion. So there is the claim that there is a blue hidden population in Westerlund 1, which belong to the cluster or be in front of the cluster. But the proper motion seems to confirm that there is a relation between this the red and the blue population. This is the kind of study that you can do when you have parallaxes, proper motion, photometry from Gaia, as we have with year 3. Now, going to the next meeting that will be held in Naples in September this year, what are the topics driving this meeting? Basically, we want to highlight the crucial contribution of Gaia to our stellar evolution knowledge, and how Gaia can efficiently improve our understanding of stellar evolution through the analysis of the high quality HR diagram that we can get from Gaia, the stellar absolute luminosities, and the effective temperature available for Gaia. And this, a milestone for this work will be, in fact, Gaia EDR3 on 13 June 2022, because while the photometry and the excellent color mindset diagram are already available with EDR3, with Gaia TR3, there will be the release of products that are crucial to have hints on the stellar evolution models. And this consists of fraction of the binaries that will be published, the catalog of binaries. There will be a catalog of about 11 million variable sources of 25 different types. And then there will be also parameters for astrophysical parameters for about 500,000 objects, mean radial velocity for 33 million objects, RVS spectra for about 1 million objects, so allowing also to measure, for instance, alpha elements in the data. With all this information coming, we want to address a number of specific topics, and these are the topics that we intend to address specifically in the meeting. Gaia discuss specifically Gaia constraint on stellar evolution models, on selected phases of stellar evolution that sometimes are also not so much statistic in the past, did not have so much statistic as is now possible with Gaia. Constraints on stellar atmosphere models, and on stellar pulsation models to extend the work, for instance, the comparison of the boundaries of the instability strip of 4 different types of variables, and interpret these boundaries in terms of temperature of the star, gravity, and absolute velocity of the star. Another important point is the constraint that Gaia can give on binary star evolution. And a crucial point is then the synergy with Gaia and other missions. We have certainly in mind to discuss significantly the synergy between Gaia and spectroscopic survey, but not only spectroscopic survey, but also, for instance, data coming from tests from other missions. And first announcement of this workshop will be sent very, very soon. So you'll hear more about that. Now, focusing a bit on one of my favorite topics, since I am a variable star person, just a brief list of what are the main types of variable sources that will be available, that will be released with Gaia DR3. You have here, as I said, with Gaia DR3, there will be about 11 million sources, 20 different types, and I have listed here some of them. So you go from the bright Cepheids, long-period variables, RLRs, main sequence oscillators, solar-like, microlensing effect, also eclipsing binaries, exoplanets, and QSO and AGN, variable QSO and AGN. And for all these variables, you will get time series data, which means you will be able to follow the light curve variation. Then in particular, for one type of sources, for the RLRs, there was an image of the week published on the Gaia webpage a couple of months ago showing the quality of the data. And here you have the light curves and the radial velocity curves that will become available with DR3 for about 1,000 RLRs. And you, in the top panels, you have RLRs that pulsate in the fundamental pulsation mode, the C-type RLRs, and the last panel on the top on the right is a double mode pulsator instead. And in the bottom, you have the light curves of AB-type RLRs that pulsate in the fundamental mode. In each panel, the three top curves are the BP, G, and RP light curves, and the bottom panel is the radial velocity curve. And for these variables, not only the light curves will become available along with the pulsation period, the amplitude, and other parameters, but also individual photometric metallicities and individual absorption values that are derived from the pulsation characteristic of the stars. In particular, I show here a metallicity map of the RLR of about 135,000 RLRs that will be released in the R3 out of a total sample which is about twice this number. And each point is an RLR stars, and the color is, the coding is in metallicity as shown in the bar on the right hand side. And so you can see in this map, these are photometric metallicities. You can see, for instance, the different metallicity of the traced by the RLRs in the halo, the LMC and the SMC, with the SMC which is more metal poor than the LMC. The region around the Milky Way disk that is characterized by RLRs which are more metal rich, and also along all the disk, you can find this RLRs with larger metallicities, and you can also see quite clearly the Magellanic stream, the Sagittarius. This is the relict of the Sagittarius, the author of the galaxy. That's a metallicity, intermediate metallicity around -1.3, -1.4. And this is just an example, and it will be very nice to compare this result, for instance, with the metallicity, the photometric metallicity of other surveys for these stars, for the star in Sagittarius. And I understand that there is a talk just after mine about metallicity of the Sagittarius stars. And with this, I conclude.
Thank you, Gisella, for the presentation. Maybe we can have a short question. Someone? For me, from all your presentation was very exciting. Says one citation, like data mining in the Gaia archives is still wild west. Is in the wild west state. This is very interesting. So, for how many years do you think it will be enough Gaia archive? How many years? How many years we still will be able to mine Gaia archive till we'll mine it all?
Well, I have no answer to this question, basically, also because Gaia is continuing its observations. And now the data I've shown, for instance, in the data that will be released in DR3 correspond only to the first 34 months of observations. And we have already, in DR4, there will be the 66 months. And I think that definitely there is no really a date that I can say is the end of the exploitation. Also because the more we look at this data, the new things we find. So there is a lot also of unforeseen. I mean, so, and then Gaia, that started as a 5 years mission, is now been already extended for 3 years and a half, and will likely be extended more. So ending up with a mission that is about 10 years data. I would say, well, I don't know if I will see the end of the scientific exploitation of Gaia, but I am old, of course.
Thank you very much.